Yep. Good. All right, guys. Good afternoon, everyone. Today we're gonna have a quick review and 2 exercises and a model 10. So, a quick review about what we have done last week. If you remember, last week was our model. Last week was simple linear regression. Said we have one y variable. If you remember, it's a y which is dependent variable, and we have one x. That's why we said it's simple linear because one independent variable. So x in here is independent variables, guys, right? So that's the model. The method we use square linear method or relationship, so to find the association between x and y. So there are some conditions and requirements to meet or to determine the right model to use it and do regression and find the linear regression association. As I said to you guys last week, there is 3 directions for linearity. Either positive, that means positive linearity, or positive relationship, that means the x and y going with the same direction. Positive, positive, right? Or the other, another opposite way, like the x going up and the y going down, like negative association between x and y. Or the other case, there is no association between x and y. So we have the sample, the standard error. I said to you guys, I'll also show you today how to calculate it. And also we have the correlation is important, and the slope, which is beta. The slope or beta 1 will give us the direction of the association between x and y, like in terms of positive, negative, or there's no association. So also we've done one thing like also last week was the correlation matrix, which is they give us the weight of the association between x and y, and also correlation of determination, right, is r squared, which is they give us also the weight of the association also between x and y. Normally in the statistics or in the economic studies or any other humanitarian, medical or business studies, they prefer the high square to be high. As soon as you have high, like for example, the r squared, right, equal to 80. Okay, that means just 20%, 20% of the linearity or the association between x and y is unexplained by this model. The 20 is unexplained, right? So today, what we're going to do, just a quick review while we are done. So we have, for example, also the error. The error term, that means the percentage of unexplained observations by this model. So today, when we study model 10, we try to reduce the errors and try to reduce the unexplained. How? By increasing the number of independent variables. More independent variables, less unexplained observations, and model fit the data, right? So we're going to see which one is more impact, which one of this independent variable related to the dependent variable. So that's what we're going to do today, right? So today we're going to have 2 exercises, guys. So please have a look. Just have a look to the first exercise.
During lunch. I didn't have lunch yesterday.
Yeah. Thank you for that. That was for good. to see the impact of advertising expenses on sales, right, guys? That means sales is Y and advertising expenditures is X, right? So if you check the regression, see, guys, normally such questions will be provided. By the way, before we start addressing this question, guys, normally students ignore question number 6 in the final exam, which allocate maybe 28% of your total mark in final exam. So students ignore it, don't address it because it's big, but it's important. And some of them, they don't have time. They still just spending a lot of time when they're searching in the books, the formulas and stuff. So question number 6, or the last one, let's say, will be allocated around between 25 to 30. And this question is important and is combining by 2 models, model 9 and our model today, 10. Right? So simple question will be provided like that. Find the coefficient of the regression. What is the value? So I will provide you with the Excel printout, right? Like this one. All right, guys? So I'll ask you some simple questions to find. So if you follow me today and next week with the tutorial question and some exercises during the model, so we can capture or cover the question number 6 in the final exam in total. So very important points. I will mention it, guys. Please note down on it and try to highlight it or stuff. So in here, so they ask you first questions. Right, 17.13. The exercise here said actually they want to check or to see whether the impact of the advertising expenses on sales. That is the main. But they provide with some X and Y data. We put it in the regression, right? Run, and we got an output, right? So the first questions in here, what they said, guys, what is the coefficient of the regression line using least square method? That means you predict. What's the equation in here, guys? So that's the Excel output, guys. That's the Excel output. And from Excel output, we're going to answer these 4 questions, right? So normally, first questions is about prediction, right, guys? Predict the equation. So you say y hat, you put beta 1, guys. This is beta 0. This is beta 1, right? So y hat equal to beta 0 plus beta 1 is the positive sign in here. X. That is the answer. But maybe, guys, this is important. In the final exam, because the question, I think, will be allocated some important points from the multiple regression. So in multiple regression, we will add another independent variables. So I will give you one example today to see how we go with it. Right? So that is how to predict the, by looking to the Excel output above, you can see the prediction will be y hat. Easy. But in the final exam, as I said to you guys, don't forget, I will tell you which one is important within our model 10 today. So each additional advertising dollar, sales will increase. So what's the next, the second point, guys? What they said?
Second question.
What does the value of intercept tell you? If you got such a question, guys, what do you say? You said, tell us nothing. That's it. Why? Because it's a base of the slope regression, which is, in this case, x equal to 0, right? So that is the slope, guys. That is the shape yx, right? See why it tells us nothing. So when we say tell us not, that is the value of intercept. So x in here equal to 0. So that means beta 0 tell us nothing. Right? All right? So you just say tell us nothing. Okay? C. Intercept is 0 every play, yeah. No, x equal to 0. No. It's not intercepted. Right? Yeah.
That's providing it in the summary output.
Yeah. So if the intercept, at the intercept point at the start, x equal to 0, that means intercept tells us nothing. But beta is a coefficient, the slope value, which is y divided by x, so it will give us the linearity of the association between x and y, right? So the value of intercept tells nothing, right? Oh, sorry. What's the third requirement, guys? Third one?
Interpretation of the slope coefficient.
Coefficient.
Yeah.
You just see the sign of the slope coefficient. So check this sign. So here is positive, right? That means if we add the positive association between x and y. So x the expenditure and y is the price, right? So any increase in sales, right? Any dollar increase or additional advertising dollar, that means any increase in expenditure expenses, right, will lead to increase in sales by the value of the intercept. The beta 1, the slope, right? Beta 1 is the slope, guys. Beta 1 is the slope, right? I mean, because the sign in here is positive, guys. See? So if it's negative, that means the association is negative. Any additional increase in expenditure lead to increase in the sales. For example, right? What's the assumption? Last one, guys. They assume that, right, guys? They assume that if the sign is negative, right? That means if the sign of slope in here is negative, what does it mean by that? That means any increase in, right? High advertising lead to decrease, result in low sales or decrease in sales price. That's it. The sign is very important, guys. The sign gives you the direction of the association between x and y. Right? But some assumptions also important, like if something like that, what do you think? This one is sometimes will be provided. Spin is not good. All right, guys? Easy, right? Do you remember what I said to you that this model is very easy? So, how about next exercise? Go ahead with it, guys. Try to address the first one. Almost same. We provide the stuff. That's the Excel output.
Is this an over here at 10% significance level. You know the summary output.
Not the p-value here. No, it's a 30%. T start. 4.36. T stop, that one.
Oh, I see.
It's still very strong, significant.
Yeah.
You remember when I provided you with the guys, with the one at 1%, 5%, 10%?
Yeah.
That one I'll give you because this is important. But I want to discuss during the what happened, guys. We have p-value and we have t start. This both indications will give us the significant level. All right? What happened? Now, for example, t-stat in here. So t-stat, all right, equal to 6.23, right? What does it mean by that? Guys, if you remember when we was analyzing the or testing the hypothesis, I said to you guys, significant at 10% start from 1.65. You remember it? Model 5. Trust me. I'll show it to you. It's in here.
Throw it to the table, yeah.
I'll show you. I'll show you. Still, we have time, and it's a very by the way, the regression, simple and linear. I mean, the simple or multiple today is almost in terms of the conditions, but very important to recognize the nature of the association, the nature of the model, the nature of R squared. What is the R squared? What is the standard error? This is the keys in here with this model. This is very important. By the way, we've done the statistics since February till now. We are looking for the regression. This is the important part in our unit. Because when you have data, you collect the data, you can do the summary. Okay, I have 30% in this in assets, 40%, blah, 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 in terms of the mean, median, mode, standard deviation, and so on and so forth. This is the descriptive. But if you are working with any company or among the government association agencies and you want to do some to study some habits or case in the community, for example, you have to do the regression to see whether the increase in the, for example, oil prices on the social welfare sustainability, right? So how to do that? You have to have oil price as an X and social responsibility or social welfare or sustainability as a Y. How to do that? You have to have a knowledge and the regression. So you have to recognize which one is X, which one is Y. What's the theories? What's the studies? What's the model? What's the R square? What's the stuff? Which model will fit the data? So very important. Very important, the regression. So that's why I see you guys. If you go back to model 5, and here, computer very slow. Okay, model 5. Okay. The script is hypothesis testing. Significant. That one. 10%. Significant at 5%. Significant at 1%, which is very strong. So when we run any regression using Excel, SPSS, Stata, SAS, MATLAB, any software, the significant level will be same for all of the softwares, but there's some differences in the function of the software, but the percentage is same. If you got T is 164, normally we say 165, 1.65, that means it's significant at 10%. Significant, but not that much strong. Here at Fonte, we got T, for example, at 1.96. That means significant at 2 star, which is good, acceptable in the studies. All right? But if you got up a significant at 1%, that means your study significant at 3 stars. That means you got very good association between X and Y. Very strong, significant statistical association. In terms of positive or negative? In our case in here, we got negative. But that means, but it's significant. High expenditure will lead to strong drop in the prices. Significant at, start from here. From here to here, from 1.65, for example, to 1.69 is 1 star in here. That's why when you check any study in accounting or in finance, they do some stars. Right? 1 star means significant at 10%. Even they explain under the table, they give some explanation. That means 1 star, significant at 10%. 2 stars, significant at 5%. 3 stars, significant at 1%, which is very strong. Right? See the link between the models? If you miss one, so, right, guys? Okay. So in here, they ask some question, guys. Try to address the first one. What's the first one?
On the equation.
What's the equation? Done?
Yep.
The equation?
Yep.
Okay. So it will be y hat equal to 4.9. By the way, guys, in the final exam, just take two decimals, please. Yeah. 2 decimals is enough, because here there's a lot of decimals. 2 is enough, huh? Here, 2 decimals. Minus 2.6 is because of the value of beta 1 is in the minus, okay? And beta 0 in positive, and that's why we put 49.29 minus 2.5. So that means the association here is negative, right?
Yeah.
Okay, sorry. What's the second requirement?
Is there sufficient evidence?
Yeah, at 10%, significant level to allow us to conclude that the negative linear relationship exists between price and sales. Right? So what you have to do, you have to test the hypothesis. Here is hypothesis testing. So, what's the hypothesis, if you remember last week? Was? Because you have...
Beta 1 equals 0.
Yes, beta 1?
And the alternative is that beta 1...
Less than, because negative...
Yeah. Okay.
Right? Less than, negative, sorry. Right? Negative association. If you read the question, see, there is sufficient evidence to conclude that the negative linear relationship between exit, even the negative is sign will give us here is negative, right? Okay? So then, T-start, we check the model from which table is that? So here we can use p-value.
Can?
We can't use it because it's too small. So prefer to use rejection region. Okay? Right?
Why can't we use it if it's too small? I thought if it was small, it was a strong.
No, if it's 4.3, for example, 0.23 e some value, that means it's too big.
Oh,
We
okay.
have to do the calculation. Do you remember last week was divided by 10 power 13,
Yeah, yeah.
right? Equal to very small.
So if it is that, you can't use it.
At this, if the p-value, like in here, but it has to be for the beta or the y variable. in here it's too big. We have to say 4.88 divided by 10 power of 5. Right? So to find the p-value. But in here, p-value for price, which is too small. So it's better to check the rejection region. Normally, we need the rejection region because we want you guys to see whether you are using the right table, the right formula. So in here, this is hypothesis testing, guys. This is model number 5. See? T less than minus T. The one I showed to you now. T less than minus T alpha and minus 2, right? So 2 variables. So that means T 0.1 and 8, which equal to 1 point. This is from table 4, right? So what do you think in here? Are you going to reject or accept null hypothesis? So you can see that the T-stat, guys, this is the T minus 1, right? Minus 1.397, right? So what is the T? Okay, here. So do you remember the rejection region? Right? So T will come in here. So what I done was a decision? Reject at 10 significant level. Okay?
Yep.
Because T falls in the location region. Okay? That's model 5. There is a negative linear relationship between price and sales. Because the hypothesis, null hypothesis says there is no linear relationship. But we believe that, or we want to test or predict that there is negative association, which is alternative hypothesis. Right? Cool? I don't know what happened before. So, well, that's easy. Just because we're testing hypothesis. So C, what do you think was C?
What was C? Calculate the coefficients of correlation and determination. Ask me.
So in here, the relation is negative, right? So the value of R is a negative because the linear relationship is negative. So we take the R square and we take the square root of R square to see the negative association. This is one of the points last week. So because the negative association here, we want to see the coefficient correlation and determination. The determination equal to 83, which is very strong, right? But the coefficient equal to coefficient in here, the square root of the determination, correlation of the determination, okay? So which is square root minus square root of the coefficient of determination equal to minus 91%. Right, guys? Okay. So you can see the R square is very strong, 83. That means, what does it mean by 83 now? That means there is just 17 observation unexplained by using this model, right, guys? So maybe if we control more variables, more independent variables, maybe this will increase. The R square will increase. Maybe it will be 90 or 95. So if we add more variables, that's why our model today, we're going to add more independent variables. Right? So very important to check the direction. Direction is very important between x and y. Guys, direction in terms of positive or negative. So here's negative. So coefficient has to be in negative. Right?
Yeah.
Be careful about this one. All right, any question? Jump to model 10.
Sure. Need to bring us everybody.
Oh. All right, guys. Hi, everyone. So today we can have a new model, multiple regressions. The difference between simple linear regression and multiple regression is just to add extra independent variables. Right, guys? Just, do you remember? It was 1x. We're going to have more than 1x now. That is the differences. So the lecture outline, we have the model is required some important conditions. The condition will be same in terms of the standard error, R squared, autocorrelation, heteroscedasticity. So the estimation of any other. So if we have raw data, we have to use software with using same function, data analysis and regression. But we're going to have more than one x, means more than one independent variable. That's why we call it multiple linear relationship. So assessing the model, how to assess the model, to see whether the model is fit the data or not, and then regression diagnosis, right? So this chapter will extend, that's why we combine both chapters in the final exam. And then question number 6. And we'll provide some questions to you guys to answer, but it will be easy. So we'll expect this model to fit the data better than the simple, because we're going to have more than independent variables, right? So if you remember last week, the example was about the odometer and the price of the car. So we said, maybe if we control or if we add more independent variables like the color of the car, the model, so will be R square will be high, and we will reduce the error terms, and then the model will be fit the data more compared to the single linear regression or single independent variables. So that is the steps, guys. We're going to use computer printout, same. I will show you one example, how to run. And we'll check if the model is useful, any other required condition related. For example, sometimes if the dependent variables is the raw data, we have to do some calculation. For example, if we test the cache, all right? So let's say we have y equal to x1 plus x2. So y, for example, it's cache. And cache equivalent, right? This is a counting term. Cash flow statement, right?
I don't know what you're talking about.
Yeah, but you didn't attend the last. So here we have the size of the firm. Size of the firm measured by? Okay, measured by total assets. That's X and Y. So X, cash. So when we collect the data from databases, the cache and cache will come as a raw data. If we run we see that the result is not, there's some flipping out, flipping down. The error maybe will be, maybe if increase in y, the error terms will increase. So that's problem. What we have to do, this what we have done before, or what the researchers done, or the studies, they have to divide, or first they have to take natural logarithm, or we call it log, of cash and cash equivalent. This is 1. Or you can say total cash and cash equivalent divided by total assets. So the number will be ready to use and will be fit the regression. Firm size, so that's the y. So x, total assets. It's not reasonable to use the total assets number, and you have to use some statistical shape or figures, like total assets. It has to be, it's measured at the firm size, but it has to be natural logarithm of total assets. That's the measurement of assets. So we have to do some calculation. That we call it diagnosis. I will show you how to do it later at the end of this model. So employ the model and see the coefficient, predict using the predictions equations. Sometimes we see the literature to see which theory is it consistent with the literature. We have to test. We have to check also the independent variables. I'll show you within this stuff. So that's the model today we have, guys. We have beta 0, y equal to more than independent variables, guys. Okay, you have more than independent variables. Like, for example, when we predict the price of the car, okay? Right? We use here odometer, right? Here we're going to add, this is last week. This is last week, okay? Last model, model 9. 9. Here in model 10, we're going to add color of the car. We're going to add the age of for example, model of the car, Toyota, Holden, something, it depends. The price will be determined more accurate by using additional independent variables. More independent variables, high, R-square will increase, and error terms will decrease, model will fit the data more accurate compared with the simple linear regression, because we used to use one independent variable, which is not enough. That's why they use the more than one independent variables to test the association between x and y. So, okay. So the simple linear regression, we're going to have just, we used to have one x, but with multiple regression, we're going to have negative or positive x. So it depends. Like when we control, so that's the model, that's a predicted model. So in here, we're going to have more than one x. So some x will be in minus, for example. Some x will be in positive. So when we say control variables, when we say control or independent variables, additional, like we add return on assets, we add age of the firm, we add leverage, we add like working capital. This is all independent variables when we want to predict the cash and cash equivalent. Because among the theories, if there's extra cash, it has to be strong corporate governance to protect the cash from the playing by executives, or some of them, they said extra cash will lead to capture more investment opportunities. But in here, we have to predict the cash, for example, as a y, and using a couple of control or independent variables to predict the level of the cash for each firm. And then we test other independent variables like corporate governance or age of the firm, the size, and so on and so forth. Right? So almost same to the simple linear regression, but we're going to have extra independent variables. So required condition, it's same exactly, same with what we have done last week. So if you remember, the mean of the residuals or error, it has to be 0 or close to be 0. The standard deviation of epsilon is consistent with standard deviation of errors. So it has to be same for all variables. Errors are independent, so any error within the independent variables, so because every independent variables locates some error level, so it has to be this error for x1 has to be independent from the error of x2, has to be independent from the error for x3, and so on and so forth. In here, the error are independent of the independent x variables. So, so for each variable among independent variables and the general one between x and y, because the association still have the some autocorrelation, so it has to be controlled. So using new modern softwares, guys, like STAT or SAS, or this sort of models will control everything by when we will capture everything by using the coding or adding some codes to capture all of these errors, autocorrelation, or diagnosis, or any heteroscedasticity. We add or do some extra calculation called indigeneity test to test whether is there any indigenous problem or not. So the conditions are required in order to estimate the model more accurate with our data to test the hypothesis about the model coefficient. So if you said that the firm size will, this is an important thing, guys, for you. Okay, if you are accountant, guys, right? So if I ask you guys to predict a model, first model, predict the association between corporate governance, okay, and firm profitability. So which one is Y and which one is X?
Profitability is Y.
Y, yeah. Correct. Measured by? We want to talk about accounting and statistics.
By in dollars?
No. Now you are accountant, right?
Yeah.
Working in government agencies or in ATO. And I said, I'm a bit worried about the profitability of this firm. Could you please check the historical data of this firm and try to formalize the total number or the amount of profitability by this firm, whether this firm are getting profit or not? So the profitability measured by
sales.
no, not sales, but I'll sit down. So profitability measured by a return on assets.
Oh, okay.
A return on equity. This is all profitability predictions. This call it firm-based measurement. But for stock market, like ASICs, they have to have their own predictions or factors to test the profitability for each firm. This we call it market-based measurement. Which one is that? Which variable is that? To test the market-based measurement profitability for Commonwealth, for example. Like you are an investor. So you want to check which firm is more profitable to invest your money. So now the institutional investors, they go to the market website and check one variable. Which one is that? To see the profitability or the market value of this firm. Market capitalization, MCAP. Now just Google assets. On the main page of this, there is market cap for each listed firms. Right? MCAP. This is market capitalization is a market-based measurement, but is a profitability measure made by the market. They have their own prediction, like corporate governance level, their like adapting the international accounting standard or Standard Accounting Standard Board, like amount of dividends paid for the executives, like amount of number of investment per year, internal trading, like some sort of subsidiaries, how many subsidiaries they have. So they have their own predictions to predict the final number of market cap per year per firm, right? So we call it market capitalization. That's a measurement of profitability for each firm, but it's a market-based measurement. If we want to test it as accountant, we want to test the profitability of Cato University, we have to go and see the return on assets or return on equity. Normally, the return on assets is the main one. But if we want to check the additional analysis to see the result is consistent or solid, we do the ROA. If there's some differences, that means there is something wrong with the model. Right? So if the profitability based on ROA positive and ROA negative, that means there is some diagnosis. Right? Maybe you did some mistake when you download the data, or do mistake when you calculate the ROA itself, right? Or maybe there's some other, maybe in the model not fit, because in advance, because we are talking about basic, in advance, we have to test which model is fit. Is fixed effect, or random effect, or ordinary square. There's three main measurements to test the X and Y, okay? But the point I want to tell you about it, guys. I asked you whether to test the corporate governance, right, as an independent, right, variable, okay? And ROA is Y, right, dependent variable, okay, profitability. Normally, when we do any regression, this is important for you guys. We have independent variables. So directly, we put it here for us. Independent variables, right? Independent, like age. Let's say leverage. Like age. Like total assets, right? Measured by natural logarithm of total assets, size of the firm, right? Like the age is normally we put it in the end, okay? So how to determine that one, guys? This one we call it independent variable. That's the main one, but we call it control variables or independent variables. So how to determine that, guys? Can we put, for example, average income for people who lives in Canning area? Why? Because the independent variables has to be determined by Y, not by corporate governance. That's why we call it independent. But ROA as a profitability is measured by net income divided by total assets, but the control variable that will affect the ROA is leverage, total assets, right? This is all corporate governance as a main dependent. We want to test whether corporate governance, but we have to control for this stuff, these variables, because it's related, very important to control to get the accurate number of ROA or amount of profitability of firms. Why firm size? We control it. We put it as a control variable or a dependent variable because if the size of the firm is big, maybe the profitability will be big.
But won't firm size also affect generally the level of corporate governance that a firm might have?
No, corporate governance is different. Corporate governance is the way on how to manage and run your business.
Right.
Like, normal corporate governance measure, this is a good question.
Yeah.
Good one. Normal corporate governance is measured by a couple of variables, like number of independent directors on board. Total number of both sides. So if the both sides is big, that means the number of independent will increase. Number of independent committees like audit committee, like risk committee. So not all firms have risk because it's optional. But audit committee is compulsory. But there is another, so it depends on you. If you're big, like Commonwealth Bank or ANZ, that means you have the audit committee, which is compulsory. It's regulated by the corporate governance codes, introduced by agency like ASICS, Australian Investment Securities, something like that. But for example, risk committee. In some countries, risk committee is mandatory, right? Not compulsory. So if the firm adapt, for example, they have audit committee and they create a risk committee. That means corporate governance level is high compared or more strong compared with firm with no risk committee. You got it? So that's why we measure corporate governance normally using factor analysis, because we have more than, like, what's the factor analysis? We extend now, but this is good for you guys, I think. We have corporate governance variables, right? We have a number of independent directors, like 6, 7, 3, 4, 9, depends on each firm, right? And here, audit committee, 1, or independent directors and audit committee, like 3, 4, 2, 0. Some of them, they don't have independent, right? So the end, like risk committee, independent variable, or audit committee, number of audit committee meetings per year. That's also measured by natural logarithm of number of meetings for audit committee per year. So we took all of these variables, guys, and make it one variable. We call it factor analysis. It's measured by Compass 2009, I think. This guy, I think 2008 or 9. He creates a factor for the weight of corporate. That's why we call it weighted index. Weighted index, or there's a lot of ways to create the index. But at the end, from this heaps of 14, 20 variables, we're going to have one. This one is different from firm to firm, right? Based on their data disclosed. Right? So you got it? It's a bit advanced or not? So it's normal, right? So that's why we call it corporate governance. But it's not mean one variable. It's one variable, but it's created by heaps of variables, like 14, 20, depend which index you want to adopt. The studies cover this one. Some of them, they create 5, 10, 14, 16, 20. Some of them have 48 variables. So it depends. It's big index. So more variables, the index will be more accurate to get one variable of corporate governance. You know what I mean? Got it? So far? Huh? So learning is not just studying. It's better to learn. And why this one? Why we do that? It's better to extend our knowledge. All right. So estimating the coefficient model. So obtain the coefficient. Coefficient is easy, as I told you guys. I will understand it using the computer software. Regression, data analysis regression. So diagnosis, we have to see whether the variables measurement is correct, or we collect the data correctly. We didn't add any couple of zeros or stuff, so it will change the direction. And normally, guys, we use the small figures of the variables, because when we have the database, the variables have to be consistent in terms of the shape of the figures. We can't put, for example, cash variable in million and total assets in thousand. So it has to be consistent with each for each variables. So we have, for example, some dummy variables. We have some some continuous or some categorical variables. So it depends on the data set. So we take the small figures, but when we interpret in here, we use the figures in the original numbers. Like when we interpreted the odometers and the price, we have to use like last week, we use the original numbers to do the interpretation. Like any increase in 1,000 in odometers will lead to increase in a decrease in the price by $94, if you remember it. All right? So we have an example in here. So they want to test the margin of profitability of the management accounting of the motel chain is planning to do some expansion. So the management accountant wishes to predict which side is more likely to. So there are some competitions and there is some market awarenesses, demand generators like number of students, employees in university nearest to the motel, like demographics, for example, the distance between the motel and the city center, for example, physical quality, that means they have some space inside the, so here, right? So competition, we have number of rooms for each motel within 5 kilometers of the site. So we have nearest to the market or city center, or nearest to Holiday Inn, because these competitors, right? Also competitors, Holiday Inn. Office space, because if the visitors or customers come to the city and they have to see the office space, guys, if it's big or not. So if it's big, so there will be more. So also university enrollment, so number of foreign students, right, who are enrolled in the university, 1,000 also measured. So community, so income, so median household income, also measured in 1,000. Distance to town, downtown, or distance to the city center. So this is all variables will determine, accurately will determine the amount of profitability or margin for the targeted motel. So that's our data, guys. See, when we say data, when we say predict in here, this y hat is a margin, right? Or y is a margin, and we have more than one independent variables or profitability, guys, right? We have room, nearest to the staff, office, enrollment, income, distance, town. We determine, that's the data is available on your data set, guys. Right? When we run, same, guys. Hello? When we run the Excel, we got the output function like we have R square, guys. Where's the margin? Sorry. So predict. When I ask you to predict the model, guys, regression line, you say margin. See, guys. First requirement. And the question number 6 will ask you to predict the model. You have to predict like that. you have to put the word predict or predicted. You have to, or estimated. You have to put this word. Otherwise, okay? I'm too strict with these points. Predicted or estimated margin. So that means I understand that you know that the margin is a y, right? As a function of the amount of intercept, right? Minus, depends, guys. Depends on the sign in here, in terms of minus or plus, right? Rooms, you put it like this, guys. Please note it down. How to predict? You say predicted or estimated margin as a function of, same as that one, equal to the value of intercept minus, because the independent variable number one is the rooms, so the sign is negative, and the independent variable number two is positive, right? So the end, distance is negative. You put the word, the name of the variable. That means coefficient times income, coefficient times destination. So I want this shape. So the first requirement of the question 6, right, will be like this. It has to be answered like this. I'll ask you to predict the model. So you just put the predict word or estimated and the rest of the variables. Right, like this. You put the coefficient and the name of independent variables. Coefficient and the name of independent variables, right? Based on, so you see, the R square will be same, but we're going to use the adjusted R square in here, guys. So I'll show it to you later. But we're going to use adjusted R square in here. Adjusted R square used when we have multiple regression, not R square adjusted. It's better to use adjusted, right? Standard error provided ANOVA significant in here, and in here ANOVA need for filter test. So in here, significant F is a measurement of p-value in here. That one is a p-value, right? Because we're gonna, here is the multiple, it's different, right? So ANOVA need for F test, significant F. So significant F in here is a p-value, right? Okay, so p-value is very low, is 0. So that's why F test is strong, because we have strong association between the X and Y. But here is a little bit different. We have to see later, we're going to test which one is independent of this. So this one is independent, 1, 2, 3, 4, right? Because significant, more than 1.65, right, guys? We go back to model number 5. 2.6, significant at? Let's start from here. Significant at? 6.05? At? 1%. Significant at? 1%. Significant at 1%. Is that significant? Why? 1.65. Good. So 3 star, 1%.
So what do we do if it's not significant?
Just a little bit. But we have to control it, because we think that, not we think, this is literally, I mean, and it's provided by the literature or significant to use, but maybe because our data measure or controlled by some regulations, this variable or some other effects, this variable is not significant. That maybe with the other study, if we study Australian, for example, among Australian public listed firms, so there's some differences if we compare Australian output with US outputs. There's a lot of regulations, like for example, the package of compensation paid for the executive is different, corporate governance rules is different, international standard, they use US accounting standard and GAAP, some sort of thing. We use Australian one. There's some difference. Maybe this will lead to some of control variable will be not, maybe because of the government setting or firm setting levels, firm level or market level setting, we don't know. So, but normally we will report that, for example, positive association between like the margin. So here's the negative, right? Nearest and margin is positive, right? Significant, right? So that one is not, there's no. Here is positive significant, no association. Positive significant, no association. Less than 1 point, right? So if it's not significant, just leave it. But we have to control it because in the literature, some of them before us control it. So we have to be consistent with the literature. Right, guys? You know how to why control? It's determined by the margin. If we want to test the margin, we have our profitability with this sort of industries, which is the social welfare, or let's say motels, I don't know what they call it. Transformation, not transformation, is
Motel chain?
maybe not the industries, the high level, because under financial firms, we have banks, insurance, and right? And other brokers. Under industries, we have the mining, some stuff. Under telecommunication, we have a couple of, but motor chain will be under the, I think it's tourism, correct, tourism, because, but how about the transport and tourism, I think, like that, because it has to be also some transport companies like
There's another industry group or something.
yeah, we group it together because it's regulated by same regulation, guided by same corporate governance codes, because corporate governance codes for financial firms is different than corporate governance codes for non-financial firms. Right? We group it together to see what's the effect. So we have to group it to compare with, for example, other industries and stuff. Right? It's too sensitive when you do regression. Otherwise, if you do some small mistake, the direction of the association will be changed from positive to negative, or maybe you can find an association which is, so just spending, burning time and no results. So it's very hard, right? So, got it, guys? So I'll show it to you how to. So we have to compare. Do you remember last week, guys, when I said to you y bar, how to calculate y bar? How to calculate y bar is the mean of y value. Like profitability we need the y value, y bar. The mean of y, like value number 1 plus 2 divided by number of observations. You got y. Or if you have Excel just highlighted, it will give you the average value. The average value of y equal to 45.7, right? 3. What's the standard deviation here? Equal to, from the question, Marco?
Standard error 5.52.
2, yeah, divided by 4.5 equal to 12 point. That is the error terms. What do you think, guy? It seems that particularly small relative to, okay. That's a question, guys. See, guys, that's a question. Can we conclude that the model does not fit the data well? What do you think? Do you remember rule of thumb? Yes, good idea. If less than 20%, if the error terms, if it's less than 20%, that means the model fit.
It fits.
Because it's an error. That means the error less than 20%, which is good.
Rule of thumb. Is that what it was called?
Yeah, model 9, if you remember. So
it was
can we conclude
standard
now?
error divided by y hat is less than 20%.
Yeah.
Can we conclude as long as not? No.
Y bar. Y bar.
Yeah.
Not hat.
Y bar.
Yes, the
Y
average.
bar.
How do we calculate y bar again?
It's the average.
Yeah. Which one?
Where did you get equal y? Where did you get y?
Y bar.
How do we calculate
Oh,
that again?
good question.
Yeah.
Go to the back to the raw data.
Yeah.
There's no time. Sorry.
Or
Go back to the raw data. Which one is that? Which example is that? Number 18.1, right? Or 18 point, this one. XM, because there's XT. So let's go to the databases. So which one we have? Margin. Just highlight it, sorry.
oh, that's right. Yeah.
This one, average.
35. Okay, and that's the average.
Just highlight it.
Oh, that's literally just the average.
Yeah.
Or,
I was expecting something fancy here.
or you can say here, guys, equal, a lot of ways. Or here, see, guys, here, there's formula. Formulas here. Think, so from here, you got statistics. See, everything. Mean, natural log, everything. Here, insert. So, or you can say directly here, equal, average, this one, average, right? And just highlight it, this one, like that, right? Pop, tick. Which one is that? 45.7. See? Got it?
Mm-hmm. So it's just the average
Of
profit margin from the data set.
average Y, average of Y,
In
which
this
is the
case.
profit, yeah, in
Yeah,
this
yeah,
case.
Yeah.
Maybe price in other case, maybe stuff.
Yeah.
Cash and cash equivalent, Y bar for cash. Got it, guys?
Yeah.
So far?
Yeah.
So you have to go back to the. So how to run? I'll show you how to run, guys. Okay. How to run? Sorry, you know how to run?
Yeah, no, that's right. Yeah.
You know how to run? Sure? Data analysis. See, I'll give it to you. See, guys, okay. Let's spend 2 minutes to run. In here. So you have a lot of options to run, guys. Here, we're going to go data analysis. So regression. Right? So, okay. So we're going to have just highlight it all like this. Okay? Labels, output. We're gonna have in here, we're gonna have, you want, for example, linear fit plots, you have profitability plot, up to you. But that one is enough in our case now. Okay? So we're gonna have this one. That's the output. So normally we highlight it and just say pick. So it will give us the right numbers. All right? So that is the stuff. Same, huh? That's it. Just highlight all the independent variables and put it in the column of independent variables because it's determined already. Okay? Where are we up to, guys?
Standard error estimate. Yeah.
This one done, huh? So can we conclude?
No, we can't.
That right. We can't conclude because
Sorry, man.
no, that's fine. So from the printout, the R square equal to 52%. But because we use multiple regression, guys, it's better to use the adjusted R-square. That's the difference between linear. Some minor differences. Is there minor or major differences? What do you think? Right? So 49% of the variation in Y, profitability or margin, is explained by the linear regression model format above. Right?
But they're asked what an adjusted R-square is.
Pardon?
Well, how do they adjust it? What's an adjusted?
No, it's in the Excel output. No, it's important. Thank you for this question. Yeah, I agree with you. See, this is adjusted R-square.
Yeah, but what's, in theory, what's the difference between an R-square and an adjusted R-square?
I think R-square is almost same to the coefficient. I'm not too sure exactly, but this is my, because of the experience working a lot. So R-square is give you the variation in Y and how, to what extent can explain by X. But in here, so normally they say it's same to the correlation coefficient. Normally, same if it's 1 and 1, because coefficient measure coefficient of correlation. We call it correlation matrix, which is that one. It measures the variable and variable, 1 to 1, 1 to 1, 1 to 1. One independent, one dependent. One dependent, one independent. Independent number one, right? So like, I'll show you. Okay, I'll show you one paper published. I'll show you one paper published. Google Scholar. Right? It's good to understand. So that's first paper published, 2016. That's mine. Major Market Review Journal. See, guys, this paper we have Y and Y as a couple of X's, right? Yeah, directorship formula, it's a bit complex. See, I just want to show you the regression. See? That's the regression model. We have a couple of measurement of busyness. Means directors who have more than 2, 3, 4 directorships outside the firms, multiple directorships, right? And we said if the family ownership related to this, family is independent and business. So we control all these variables as independent variables or control variables, because we think, and this is supported by the literature, that this variable Y, this independent variable is determined by Y, okay? So let's see the association. So that's why we say 1 star, 10%. Here, this is the first analysis. So this one is the coefficient, correlation. Correlation matrix, guys. This is my pen. See, guys, the correlation matrix. So it gives you, so this one, busy. So let's see family ownership here. 1, 2, 3, 4, 5. 5, right? This is family ownership, right? Family ownership. 1, 2, 3, no, 4, sorry. 4. But this is also another family ownership measurement. Here, 4, family ownership. So family ownership with busy, 1. Family ownership with busy. So you know how to measure? So it gives us the association between each dependent and independent variables. So dependent 1, dependent 2, dependent 3, dependent 4, independent 1, independent. So each, so like this, that's why it becomes like squid to the right-hand side, right? So it gives you the association. For example, the amount in here, right? Positive, significant. Why? Because the regression tells us that the busy positively associated with the age of the firm. For example, this one. It tells us that family ownership positively associated with the busy 2, this one. Sorry. Yeah, 2. No. It's family ownership. Yeah, with busy, number 2. See? See, it gives us the association between 1 and 1, 1 and 1, 1 and 1, 1 and 1. Couple of y and couple of x. But I give you the association between 2 variables. Right? With the adjusted one, guys, as, what's your name, sorry? Jaren. Adjusted because we have more than one R squared, so the software adjusted once for the whole model with a couple of independent variables.
So just because there's multiple R squared.
Yes, but with the linear, use R squared.
Right.
I think with the linear, there is not. But linear, yeah, we use the R squared, but for adjusted one, for multiple.
So the adjusted R squared was in.
I don't think so. Check. I think almost same or close to be.
It's there.
It's there.
In the output.
But in these studies, no, because what happened? Excel is very basic software. Now I use Stata, for example. It's in my office. Stata give you 1 R square. No, I just did no stuff. No, that's it. Thereafter, R square. Here is error. This is not good. It gives you full report. Even the star. Now we develop one code. It's the tab we call it. It gives you the star. If it's 10%, it give you no need to check whether it's 10% or not. It gives you 1 star directly. No need to just put a note that this one. So this one, do you think I put this manually? No. So I didn't put it. Software give it to me. See, that's the correlation matrix. See the regression model. The regression models. So the stars gives by the software. Directly. So this is independent, and this is. See 1, 2, 3, 4, 5, 6 regressions. We put it in one table. We create a model, like this, run. It gives us this table ready. Copy and paste. Even there are some codes converted to the Excel directly. Ready, shaped, clean, with stars, everything. Right? Okay? Where we go, guys? Are we up to? I forgot the model. Done, huh? This one? Ah, this one. Okay.
So, sorry, can you go back to that last slide?
Yeah?
In a judgment on that correlation.
Okay, correct.
So,
Normally, in the studies, there's no specific, but if you study, for example, some association between X and Y, there was some or couple of authors studied before you. So, but you apply this case in Australia. For example, you want to see the level of, for example, cost efficiency among local governments. We have one study like this one to see the level of sustainability or corporate social responsibility by the local government, because they spend a lot of money. But is this one used efficiently to reflect that on the people efficient, sustainable or social welfare, right? Okay. And some of them done some studies before us. So our R square and error terms has to be same or close to them. Even the mean and median and stuff has to be same to them, or close to be them. So in here, the R square, if it's greater than theory, this is the statistical, let's say, not regulation, but statistical accepted level of significance. Let's say that. As if r squared greater than 30, it's good. Because nothing optimal in this life. But if we do something, we got 30%, maybe some of them after us, maybe he will get 60%. Then in this case, this study, he will say that my study is different than Baban and Marco and other guys because they got R squared is low compared with my R squared because I control for additional and independent variables. This is the. So now, if you test cost efficiency, you have to use same variables, same, and your mean and standard deviation has to be close or same, almost same. So otherwise, you'll be questioned that your study is totally different. What's the reason? Did you control for more independent variables? Or did you miss some of control variables or independent variables? So when we say independent variables, mean control variables. So in this statistics, Y is dependent variable, right? But in your textbook, they said is a little bit x1 is independent, right? Variables. x2 in the real life, in statistics, we call it control variable. x2, x3, x4. We call it this one. We call it control variables, right? We call it control variables because this one determined by. Don't forget this point. Determined by y. Don't determine by x. But that's why we call it in your textbooks independent. Independent from this one, but it's control variable for y.
Is x3 independent of x2?
Everyone has to be independent.
All independent of each other.
That's why they call it independent. In your level, they call it independent. Call it independent. Don't call it control, please. But later, you will see that it's control variable. Because it's determined by what? All right, so testing the utility of the model. So in here, because if you remember, B1 was equal to 0, right? Remember that one for simple linear regression? Here, B1 and B2, 2BK, number of. So in our equation, we have 6 independent variables, right? So equal to 0. At least, that's the alternative, guys. Please highlight it. At least one of BI. So imagine, maybe I will ask you in the question number 6 to shape the. At least one of BI. Sorry, we didn't take break.
We're all rolling.
You alright, guys?
It's okay.
No. So at least one of these BI variables like B1, B2, B2, B6 not equal to 0. That means if it's not equal to 0, that means reject null hypothesis and take 10 minutes break. Sorry guys, sometimes I extend the knowledge. It's for you. So please forgive me. So don't say in the evaluation that this guy goes some advanced stuff. That's for you guys, but it's good to understand. We're going to leave in some stuff later. We will spend a couple of hours to. All right? So enjoy with your 10 minutes break.
Came this morning. You know it.
I was waiting for you.
I swear to God, man, I came at 10 a.m.
No, that's fine. Come tomorrow afternoon.
Okay, sure.
So because you still have time, I
Yes,
didn't
sir.
reply you. I will reply you today to
Thank you,
confirm.
man. Yes, sir.
Don't worry, it'll be fine.
I'll see
I'll
you
give CC also for. I'll tell you that the deadline due date will be that one and stuff.
Sure.
So don't worry about that. Yeah,
That's fine.
yeah, no worries. Nathan, it's statistics. Don't work in the finance.
It's due
Well,
tomorrow.
we
Due tomorrow.
It's due tomorrow.
Ah,
He hasn't
really?
finished.
So that's fine.
Yeah.
What's the? You see?
Harvey, I don't know his last
Who?
name. Harvey. I can't pronounce his last name. Finance.
But
yeah.
he's good at it. Stuff.
His name's not here. No.
I did this last semester.
And FCF, huh? Free cash flow. I've done a lot of calculation. I have when I've done some because I have one published paper in last November. It's available on Google School. It's in cash order. So it's cash flow, free cash flow. It's one of control variable. And then before income and tax.
Oh, this is your. Just add it, right?
Yeah.
No, still start yesterday night. Just look at it. It's a weekend.
When you mark my
No,
assignment,
no,
just
I
notice
didn't
there,
mark
I
anyone,
just
but I'll
put
finish it.
the
I'll
row.
finish it within the
Just
weekend.
like, just
Maybe Monday.
Very quick.
I'll try because I know the solution by my.
Yeah.
Because heaps of emails and heaps of consultations out of consultation hours being done with the student. So. If
Hopefully we did okay.
No, most of the guys will be alright. Most of guys will be okay because I've got some empirical questions like if someone asks me some specific question by email or doing something, I can determine the level of knowledge based on the question.
When you read mine, have a few whiskies or whatever, and that way it might read a bit better.
Yeah.
Just down a whole bottle, yeah, and then start.
I'll start today, mark it out, but maybe I'll start question by question. Because I'm question one for all students, and then question 2, 3, 4.
That's what I used to do when I taught high school. Makes
Ah,
it easier. You
They
do-
make it easier. And
do
then
the same question over
same
and over
question.
again. Yeah.
So even last semester and semester before, 2 semesters before, for the same unit, I was a marker. So I'm follow this policy, one by one. But this level of the students, this semester, I think there is some improvement. There is some improvement compared with previous. So last semester was better than semester before. I feel,
Getting
but
better.
unfortunately,
Yeah, I
less
think
attendance.
I think
for
it's,
students because of assignments and stuff.
this week is
Final.
pretty intense for most students in,
Oh.
in the courses I've been talking to.
I'm shattered. I had work yesterday, so I lost the whole day.
So you just have 4 units, right? Guys?
4, yeah.
4. Some of the students have 5.
Oh wow,
Yeah.
overloading.
Yeah, well, because international.
Right.
Maybe there's a
Oh, I've got to get it
stuff,
done quickly.
you have to
Yeah.
finish it quickly.
Oh
And
my god, 5.
5 is
A lot.
a lot. Yeah. 4 months almost.
Yeah.
Within 4 months, 5 units. Advanced, you talk about months of student.
Mm.
It's right, you're doing the easy stuff, but
And it's heady units. You talk about the data analysis, intermediate, tax, right? You have one tax?
Yeah. Is it fundamentals of Australian tax law?
Just when you talk about tax as a word in Australia,
Yeah.
you can think a lot of
Yeah.
regulations.
Yeah.
Because I thought that yesterday was my tutorial with the undergrad students about tax, current tax liability and current assets, how to calculate, how to prepare the sheets, stuff. But we try to give them the basics.
Is that for financial accounting?
Financial account 2005,
This is the undergrad?
undergrad.
Undergrad.
Because 2006 is leases, like capital expenditure, like share capital, foreign currency, cash flow statement. This is for account 2006. But account 2005 is more basics. It's more similar to the account 1000. But there's some also like inventories, like some like tax, like some basics.
Yeah, I did financial accounting last night.
Oh, intermediate. Yeah.
Intermediate with who?
Then,
And I forget how to say that.
Intermediate financial accounting. This for
Yeah.
master students.
yeah,
What's the topics in this unit?
well,
Consolidation and stuff, inventories.
I don't think we don't do not consolidation. That's intermediate corporate, not intermediate financial.
No, not consolidation, but inventories like
Yeah.
tax, like
Payables,
So we
receivables.
accounts payables,
So like you
receivables,
said, we did tax last night.
Oh, deferred tax? Yeah.
deferred tax, the worksheet and formula, some T accounts, profit plus all this stuff.
Well, we just started that, yeah.
Easy.
That's more next week. But as you said, with international students, really, they were freaking out for the mid-semester exam. Just the GST, just the mention of GST, and they just go over it.
Yeah. So did you use software with it or not? With this one? But for undergrad, you give them mail. Yeah. But not for tax and stuff. Just the basic stuff at the beginning, like transactions and journal entries. Okay.
Yeah, we did all old-fashioned.
It's all journal entries, isn't it? Yeah.
Sometimes there's some empirical stuff, like when you do inventories and stuff. There's some calculations.
Yeah, there's some calculations, but it's
But then you have to put,
That's just to do the journal entries.
yeah, 5 on 1.
Like
But
weighted
5
average.
Yeah. First in, first out.
Yeah. Last thing first.
Last in, first out. Life on life. So season,
That's my easy subject. It balances this one out.
so season accounting. So there is some technician stuff and there's some theoretical stuff. So especially for the human financial accounting, there's some topics. Let's just talk about the structure or the theories, or because you have to link it and follow the accounting standards. So there's some concepts is unclear for the accountants, so they have to go back to use the standard. Where, for example, when you estimate the tax losses and you have some, for example, government grants, not taxable, or some, for example, loyalty revenue. For example, let's say, so it will reduce your tax losses. So at the beginning,
You can't claim them.
deducted. It depends on if you have, so you can't, it's untaxable amounts, but and when you prepare the sheet of tax sheet, so it has to be like you have to add, for example, all the amount that you report that it's will reduce tax income. But when you deduct, it has to be deducted first. If you have losses, has to be added and then deduct the loss because it will be associated with the loss, tax loss from this year and the previous years accumulated. That's so some technical concepts and some theoretical, some international and ASAP, so I can start both number 126, right? Deferred tax.
I don't think in intermediate financial
I don't
we
think
don't
we have to go to that
the-
level of actually specifying.
in that unit we didn't
No, but
look at
it
scale.
doesn't say it to the account. No, but there is some concept you have. I think, like 2006 related to intermediate corporate accounting. Accounting 2006 for undergrad.
Yeah.
Accounting 2005 linked to the financial reporting.
Should be similar.
Linked and similar, almost similar. There's some
Intermediate
like,
corporate, intermediate financial. Is that what you're saying?
it's financial accounting reporting
No, it's
accounting 2006.
So
Oh,
we're just replicating what they do in an undergraduate.
No,
Yeah.
there's some little differences. Like they have consolidation. There is no consolidation for accounting 2006.
Right.
There's some little differences.
Yeah, yeah.
Like tomorrow, our tutorial with the guys, tutorial question is Kengisi company. This Kengisi company, same for the tutorial question for undergrad. Same.
Cash flow.
That's why when I see, I remember this name. I go back to the material because I have everything in my own. I found this Kengisi. Nothing to prepare. I know. Right? So,
Just stop.
all right, guys.
You mind us interrupting, Nate?
Yeah.
All right, guys. So let's. About to finish our material. At least one of these not equal to 0, guys. That means model is useful. So to test the hypothesis, guys, we perform analysis of variances. NOVA procedure for the F test in here using F statistic. So p-value, smallest value of. Do you remember this one, guys?
Mhm.
Small value of alpha, like if the p-value less than alpha, that means the rejection hypothesis. But I encourage you guys to use the rejection region.
Instead.
Yeah, it's better, more safe. Because now, guys, if you don't have Excel output or not, let's say, advanced statistical software to find the significant level. So maybe if you do it manually, you have to use the critical region. It's better because the level of software that we have does not give us the functions or optimal functions to find the real association between X and Y. So if p-value less than alpha means reject null hypothesis, right? So, but normally we use F-test. So how are we going to use F-test, guys? See, I will show you. So, where's the pen? So in here, so Excel provides us with the following ANOVA output. Nathan.
I'm just going to send it to myself so I don't lose it. Sorry.
So ANOVA in here give us the significant level. How to test, guys? So F test equal to 16.99, right? So significant F, I told you, which one is that?
P-value.
P-value with the multiple, right? So how to test, how to check if the P-value less than alpha? How to check that, guys?
It's 3.73 divided by 10 to the power of 13.
13, good on you. Right? And here, this one. The rule is if p-value less than alpha means reject null hypothesis. Okay? That's a rule. Let's see how we measure. He said equal 13.73 divided by 10 power 13. Very, very, very small value compared with the significant, or alpha equal to 5%, right?
Yeah.
Alpha, the default one, alpha.
Yeah.
Right? So in this case, what do you think?
Reject.
Reject null hypothesis because we met the condition in here. P-value less than alpha, 5%. Right?
So what if it wasn't the rejection region?
Huh?
The rejection region, you said?
Rejection region have to go to t-test.
Yes.
Yeah, the model number 5. So
So would it be t is less than minus t?
no. Check the condition of the Excel output. Here is negative or positive, right?
Yeah.
So in here, guys, it's better to use significant F. Why? Because we're going to have more than one independent variables. So that means you're going to do a lot of rejection regions, right? So go and use
So with this one, use p.
with this one, yeah. Right? But with simple linear regression, we can use both. If it's big, you have to do this one. But and most safe to use the rejection region with a simple. So what do you think? Reject the hypothesis? Because at least one of the, so in here, just want to show you how we met the condition of alternative hypothesis. Yeah. If at least one of these, so how to test that? We have to meet the, so that means at least one of independent variables is linearly related to the y. Even that, if you check the Excel output, you can find couple, I think four of, right? 4 of independent variables significant, not equal to 0. It's associated with y, right? That means significant association between. I think we'll show you. So in here, guys, if you go back to the question, guys, go back to the Excel output. So you can see that the direction of the association between x and y, because we're going to have multiple x's, right? We have room, we have, right, guys? We have destination, we have size of the land. No, this is next exercise. We have the enrollment. We have, right? Size of the meeting room, number of rooms, stuff. So if we check the Excel output, you can see that the beta 0 tell us nothing, right? Do not interpret this, the intercept, okay? But put it as a value. You said, this is intercept, the value of y or variable takes value of 0 because x equal to 0 in this case. Since if the range of independent, no need to interpret it. But see the slope, all right? For the first one, first value of independent variable. First independent variable is room, right?
Yeah.
Rooms? Is that
Number of rooms and yeah.
right? So what they said in this model, each additional 1,000 room within, see when we interpret, we're going to use the numbers times 1,000, the original numbers. Right, guys? With 5 kilometers of the Holiday Inn, the operating margin decreased on average by 7.6.
Yeah.
Right? This comes from 0.0076 times, all right, times 1,000, right? Because the margin and the rules are margin measured by 1,000, right? And the next one here, the next second independent variable, which one is that? Is competitor, right?
Distance.
All right? So in here, we find it's positively associated. The sign is positive. But here, positive by 1.65, right? The another one is, and so on and so forth for all the variables. So for each additional 1,000 students, so measured by 1,000 guys, right? So equal to 21% increase in the margin. So median of household income, and the last one is downtown. Additional think the distance from downtown or stuff, right? So that is, but you can see the sign is determine the direction of the, here is negative, any increase in rho will decrease the margin by 40%, for example, in negative. So the sign is important to decide. So in here, see guys, so I think beta I, so the most, see, you can use the t in here, but it depends on alpha is with multiple direction, with multiple regressions. So the value in here, the standard error for each one, and the intercept. See, this is the important part. Sorry, here, guys. See, as if you remember, I said to you, see the significant, 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 not significant, significant means 4 out of these 6 independent variables is associated with the margin in terms of negative or positive, because this one is negative, this one is positive. All positive, but this one is negative. In terms of positive or negative, you can use it. But when you report that, you say 4 out of 6 independent variables associated with the amount of margin or profitability of the motel for the city or stuff. Depends on the question. All right?
Yeah.
So 4 is significant, guys. 1. So you can use p-value. Sometimes this is not provided, but sometimes depends on, so t, right? So this one is significant, 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 significant. 4 out of 6. This one is not significant. Independent variables, right? So predict the interval. This one is not in your unit. Sorry, I forgot to delete it. The interval is not in your course material. So please cross something like that. What's you? The interval is not within your course material, guys. So please cross it.
This one too?
Yeah, this page in total. Yeah, whole page.
Next page.
The example, no, the example is different. The example about the case. So here, they give us some numbers, so we're going to predict, okay? Margin of Holiday Inn, site with the following characteristics. Sorry. So it's the same example. So we're going to see, guys, they give us the value of x1 and the value of x2, right? And the value of x3 measured by square meters, right, guys? And the number of students, this is value of independent variable number 4. So we're going to say the intercept times this one, guys, when we predict. I don't want to show you. I want you to understand before I show you, but it's in front of you, right?
It is, yeah. You plug
So
it into the equation.
So when we put the equation, we put the value of intercept times between 2 brackets, right? Times, right? Am I right?
No, the value of the intercept minus the.
It depends on the it depends on the sign of the intercept.
Yeah, okay.
Intercept. Depends. So in here, well, I'm talking about 2 brackets. This is 4.6 is a measurement of square meters, but we take the small figures.
Yeah.
Right? Please take the small figures because it has to be consistent. The data has to be consistent with the small figures. Otherwise, the direction of the linearity or association will be in opposite way. Maybe it will not give you the accurate value, right? Okay, that's how to put it. This one is required in the exam, guys. But again, this one is required in the exam. But I will ask you to put this one first. Otherwise, maybe half of the mark. If it's 5, you're going to get 2.5. So avoid. So estimate or predict. Estimated or predicted the stuff, right? So diagnostics. So in here, I think last week I talked about this one in details, if you remember. When we have some errors within the variable or within the model, we have to do some tests to check the errors, guys. Some tests, for example, the normally distributed, how to check whether the data is normally distributed or not. For example, if we want to check whether the data is normally distributed or not, how to test that? Using histogram, right? That's how to detect the diagnosis. Before you run the regression, you have to do some tests, right? Test the normality of the data. Is there an error in the variance? So we use the residual. So when do some calculation to find the residual value. And they are independent because it has to be, the error of independent variable has to be take same shape for all independent variables, right? So outliers, if you remember last week, I told you if there's outliers, we have to once-rise the outliers, make it within the range of the data. Otherwise, all of these guys, diagnostics will affect the direction of the variables. It will affect the direction of the variable or the association or linearity between x and y. So that's why we have to do pre-tests to check whether the model of the data is ready to run the regression, right? So we have to do some calculations. Histogram, residuals, like sort of things. So example, number 18.8. Sorry. Working at night. Sorry. I work at night. During the day, consultations, meetings, teaching, so research at night. So that's why. Sorry. A real estate accountant believes that the house selling price depends on some other related variables like number of rooms, house size, and lot size, which is land size, right? Analysis the relationship among the 4 variables, right? The price is Y in here, right? And X1 is bedrooms, house size is X2, and space size or land size will be X3. Right, guys? So the Excel outputs in here so price, how to predict, guys, and then you have adjusted R-square, standard error, significant F, small, that means models fit because we're going to reject null hypothesis, right? You all right, guys? Are you with me?
Yeah.
So far? Good. So we're going to have the value of beta 1, beta 2, and beta 3, right? Intercept. You have significant in here. That means reject null hypothesis, right?
Yeah.
Because it's too small.
Yeah.
From the shape, directly. You become a statistician, right, guys? Directly. Automatically put the p-value in here, run, and see how we go. Maybe sometimes can't complain, right? If you complain, no one will care. So significant. So sorry. So at least beta. So ANOVA to test the utility, right, guys, in here? Sorry, because I missed it. Here, ANOVA to test the utility, because you have F test, that means beta 1, so beta I, right, because we have not equal to 0, right? We met the condition of
At least one is.
yeah, is significant or different associated with the Y.
Yeah.
Right? So how to test that? Use F. Directly use F.
Yeah.
Okay? Beta I not equal to 0. Right? Or beta I equal to 0. But it's better to say beta 1 equal to this, beta 0, right? The stuff. Okay? All equal to 0. So don't forget the beta 1 in here, beta 2, right? And that one, beta 0, the intercept, okay? All right? So the significant in here, we'll check whether the reject or not hypothesis. So when regressing the price as a function of the independent variables alone, see, that is the correlation matrix. Guys, in the exam, I will provide it to you, this one. You know how to run the correlation? Same, just say correlation, that's it. Okay? Same, directly. Just say correlation and instead of regression. So this one, see guys, this is the correlation matrix. So how to test the significance between X and Y depends on the X1, Y with X1, Y with X2, Y with X3, X1 with X2, X1 with X3. That's the correlation as I showed to you guys in the example. So what it causes two kinds of difficulties. These statistics appear to be too small, and bigger coefficient cannot be interpreted as slow. So, but then I'll give you the association between X and Y. Okay? So you can see the value in here and here is highly correlated, right? Between home size and lot size for the bedrooms and with the bedroom size with these two variables, house size and stuff, right? High correlated among independent variables, right? Okay? So this one will be provided in the exam. Maybe, I think, I don't remember. Let's see how we go with it.
Sorry, how are you doing that last statement?
This one?
Yeah, so the coefficient cannot be interpreted as low.
Because in here, the number of bedroom, if you can see, is high correlated with the house size. 84%, right? Alone. And the number of bedrooms highly correlated with the lot size, right? But house size and lot size nearly perfect correlated, right?
Yeah.
So it's, as I said to you guys, is in here, the correlation, leave this interpretation, the correlation give you the association between each two independent variables. One dependent or one dependent, or both dependent.
So
It depends.
If the two independent ones are closely associated.
Yeah, more closely associated, more closely. So you can see here, for example, 65 price with bedrooms. It's not correlated. It's weak, right? But if it's increasing here, so strong, right? Perfect. This one good. Less perfect, right? That's how to interpret it. But this is because of Excel. If you use modern software, it will give you the weight of R squared. It's already, so you can decide whether collated and value of the coefficient in details. So MONA, it will give you two values, not just one value. Here's one value. So because of the software. But it gives you the association between two variables. This is the important. So the one, house size with lot size, perfect. Right? 99. So 83. So that means it's good, also good. But if you say 64, that means there is 35% of the observed observation can be captured by this, or maybe is less association. Bedrooms does not affect the price, but maybe the lot size, maybe, but there is high association between the lot size and house size. This is correct. It's acceptable, right? Remaining the volatility, guys, in here, there is some. For example, if you remember when I talked to you regarding the measurement of the variables, if the dependent variables is calculated in a row shape, we need to do some modification or transform the row shape into the log shape, for example, right? So in here to improve the linearity between x and y. So we have to do some changes on some variables. Like, for example, we have cash and cash equivalent, right? Cash equivalent, right? When we download this one from database, it will come as a raw data. What do you have to do? We have to take the natural logarithm, log, of this cash. So we're going to have small number of small figures ready to use. Or we can use another measurement. Cash and cash equivalent divided by total assets. We're going to have the small figures of the data. Will be consistent with the other. So that's why we do some improve the linear relationship between. So do some improvement to improve the association between x and y. Many computer software systems allow us to make the transform easily. Like now I use just one code. Generate cash and cash equivalent log equal to log of cash directly. We'll change the face of the life directly, right? So the software functions here, guys, and even in here they said the software make it very easy to run. So a brief on these changes, guys. Normally, we don't use all of these, but we use, because some of these variables, like take half of the y, but it's better to take the, see, they put it as the beginning. The natural logarithm of y, natural logarithm of cash and cash equivalent, natural logarithm of firm size, natural logarithm of ROA, measurement, natural logarithm of market capitalization to test the profitability, for example. So normally, or they take square power 2 for this y variable, or y power if it's greater than 0. So it depends, right? So this is the changes they do it to improve the usability of the variable itself, right? Not the model, the variable as a y. Same case, same for independent variables. So we can use total assets, put it as a independent variable. We have to take a natural logarithm to measure the size of the firm, right?
Sorry, I'll figure it out.
No, take your time. Enjoy. So in here, accountant have the data and is accountant lecturer, oh, that's not me, sorry. Right? What you want to do, want to know whether time limit affect the marking on a quiz. or time limit affect the marking of business report papers? Right, guys? Is it time limit? Really, we have time limit. Can someone come and help us? So we have a random sample of 100 students was split into 5 groups. So each group is equal to 20, right? So the question said the effect, or they want to require to check the effect of time limit on the marking, right? So you can see the first marking, okay, mark, we have, for example, we have 20 students. Maybe it will take 40 minutes if we have 24 students, or some students will take 50 minutes, or we have another 30 students will take, for example, 55 minutes, depends, right? If mark equal to that, so the time will be changed, right? If time is 50 minutes, what could be the marks, right? If the time is 60 minutes, what could be the marks, guys, like this? So this is the question. Analyze this result and include diagnosis. So we found that in here we check the significant and the R square. Right? It's almost same for both, right? Adjustable.
So this is not multiple regression?
No, this is, we want to test the first group of students here.
Ah, okay.
The time and marks.
Yeah, yeah.
Right? The time and marks. We're not not testing the groups, testing the marks and time. If the time is equal to 50 minutes, what's the marks of the, it depends, right? You know what I mean? So if 40 minutes we have, what is the marking papers or marks? So will be in here. So that's a question, right? So you can see that it's significant. The significance equal to, so we want it, very important, because as I said to you, the numbers has to be consistent and the y has to be measured with the right figure. Otherwise, there is some errors will be occurred. And here, do you remember I said to you, you have to do some tests. How to do tests? Test the linearity. Here are the normality of the data. And here we have the mean of the, it's normally, so error terms to be normally distributed, and we have significant. The model is useful and provide a good fit, but
No, I see.
significant because of the extremely small variables, I think, in here. So it's significant, and here association, p-value and t-stat, you see? It's significant, 16 points. But there is some extreme values if you go back to the check the data, raw data. That means if you see the p-value, so what you have to do, guys, in here, for the times, it has to be for the marks, because mark is a y in here, right?
Yeah.
So they do some extra test to see the standard error vs predicted marks. You can see, because mark is y, right, guys? Guys, mark and standard error, right? This is y. So increase in marks lead to increase in standard error, which is correct, wrong, sorry. So increase in marks lead to increase in standard error, which is wrong. What we have to do, we have to change the figure because there's a lot of extreme marks. Maybe the low mark will be 10 and the high mark will be 99. We have to be consistent with the median. So how to do that? Like natural logarithm of mark. To reduce the extremes values, like when summarize the values into within the average, right? So once the standard error of estimate seems to increase with the predicted here,
Yeah.
right? They noted that in here.
Two transformations. Natural logarithm of y.
So for example, take the log of y. So after that, take the log of and do another test. If we do another test, we can see that increase in y, okay, increase in y lead to same standard errors for all variables, right? There's some values, yeah. Right? So you can see x1 and y1, x1 and y1, right? See, x is same, right? But y will be a little bit different because we take the log. But x is same, right? 40, 40, right? 40, 40. But this one we took the natural logarithm. We can see that increase in y, but the standard error same for all the variables, right? Once we increase in y, y hat 1, y hat 2, y hat 3, 2y. Increase in y lead to increase, after controlling the natural logarithm of y, the error will be same for all the independent variables, right? So the error term will be same. So now, guys, so the new output, the adjusted, the R square in here will be better. Check the R square for the previous one, guys.
0.74.
So here is 0.77, which is better. That means the model become more fit.
Yeah.
Because we do some changes, we take the natural logarithm of y.
Okay.
Right?
I see.
Okay.
But before it was still useful and provided a good fit. But now it's better?
No. It's not.
Because it says here on the
No, because what happened? Because we have to control for we have to do some test to see the error. Before, when any increase in y lead to increase in the with the error terms, which is wrong. The error has to be same.
Okay.
Do you remember last week?
Yeah.
It has to be same. If we increase in y, the increase in error has to be same.
Right.
Now, when we take the natural logarithm, okay, the error will be same for all. When we increase in y, the error term will be same. Increase in y, error term will be same. It was before. So increase in y lead to increase in error, which is wrong. Now the model become more fit.
Right.
Even if you check the
But
literature.
before, it was still useful, but it's not as good a fit.
Yeah, because the error.
Right.
Very important to identify the error terms.
Yeah.
Guys.
Right.
Why?
Okay. The reason I'm asking is just because back here, before this part, it has this here.
The model is useful.
Yeah.
Okay, it's 74.
Yeah.
But the errors in here, because if you here, go back a little bit. You said histogram.
Yeah, you reduce the error.
Yeah.
Yeah, you have to do pretest
Yeah, okay.
to see whether the data is. Then when we do this pretest, we found that increase in y lead to increase in the errors.
Yeah.
That's not correct. The errors has to be same.
Yeah.
If you check the conditions.
So we've improved the model.
The model more.
For the change
we
error.
control for the errors
Yeah.
now, right?
Yeah.
Okay.
Yeah.
So now we improve it better,
Mm-hmm.
and see now the error almost or similar than or better than before in here. So the error seems to be normally the same, and the error terms compare with the before, with the before or better. So in here, guys, in the exam, the last one here, in the exam, when I ask you to find the log, if I said the time equal to 55%, right?
Mm.
How are you gonna check with the prediction in here? Log of mark equal to the beta 0 plus beta 1 times time, which is 55 minutes, guys, right? How to get how to predict the natural logarithm of mark, right? Like you say 0.0217 times 55 plus 2.1 equal to 3.323, right?
Mm-hmm.
It's not enough to stop on here.
That's
You
not
have
wrong.
to do anti-log. How to do anti-log? There is x power in your calculator. Then correct. Right? Shift and some stuff. You can use the phone. The phone you can use. That is the one because you take anti-log. So in your EX, I'll show you. So in your scientific calculator,
Shift and then just go AC.
see this one? This one. So, you have to check shift. I think that because
It's been a while since
this,
yeah,
I
I
know,
know.
This one.
is which one is that? 3 or 8?
Log.
Three, two, three.
Then
Right?
this antibating. Now we're just going to the slope basically.
No, no, it's not correct.
Alpha. Which is that. To get that.
Shift.
So you don't know the mark. You're trying to solve for the mark. So this
Yeah,
is
this
what
one.
you're doing this.
This
You're
one.
going,
E hat. E hat. E hat for online student. 3.323, right? 0.74. So now you're gonna shift on that one. E hat. So E hat. So the scientific calculator it become like this.
to solve for x is there we go.
Shift and E hat and put the 3.3 open the brackets 3.323 and enter. You're gonna have 27.743. So I don't want you to stop on 3.323. I want you to do the anti because your answer will be
It's a mark.
less than marks. So mark it out. So make sure you answer the question in the original variable. And that's all today. Anti-log is the inverse function of the natural logarithm, guys. Because we want to interpret with the original number, right? Because nowadays the computer software's functions give you the final number ready. But in your exam you have to do the anti-log. Anti-log, E hat, put the number, and enter. All right? Any question?
Where are we getting the errors to the histogram?
Hmm?
You're looking at the histogram. Where are we sorting the errors?
No, not this one. There's no error. This is
They just provide.
here. An error which error you talking about? This one here?
Well, no, to get the histogram.
So Histogram is normally distributed,
How do
isn't
we
it?
know that?
In the exam?
Given to us.
Given to us.
Maybe not, because I'm not going to ask you maybe about it. But I'll ask you some extra stuff. This one, predict
If
R squared, coefficients, stuff. So that's the nature of the questions. But this one is important, this one, by the way.
this one.
This one is important.
Okay.
Okay? But in normality, that's why this is just the steps on to test the data, guys.
Mm-hmm.
You have to test the data before, if you have some data and do some regression. But the sample size is big, what we said. Which one's that?
Central limit theorem.
Good. Central limit theorem, huh? All right. Any question?
Not currently.
No, I'm still doing homework. Yeah, there I go.
Oh my god, what a week.
So, all right. All the best.
Yeah.
Good luck, and we'll see you next week, huh?
See you tomorrow morning.
Then talk about.
We're off tomorrow.
Yeah.
Tomorrow we have cash flow. Kengisi company, huh? All the best, guys, and
Thank you, you too.
with your assignments and stuff. Ad hoc stop.